Welcome to SAT 021. The topic of this lesson is system of equations. A system of linear equations, also known as a linear system, is made up of two or more linear equations that share the same variables. Here is an example. So we know how to graph these two linear equations, right? How about we graph them and see what will happen? The first linear equation, y equals 2x minus 1. This one is in the slope-intercept form already. -1 is the y-intercept. It's a point 0, -1 on the y-axis. So we plot it first. And then the coefficient of x, which is 2, that's the slope. And we also know slope is rise over run. So from 0, -1, the y-intercept, we're going to move 2 positions up and then move 1 position to the right. And that will give us the second point, 1, 1. We connect them, and that's the graph of the first equation, y equals 2x minus 1. The second one, 2x plus y equals -5. This one is in the standard form. And if we are given a standard form, a linear equation, the best way is to graph from x and y-intercept. Let x equal 0, solve for y, and then that is the y-intercept, 0, -5. Let y equal 0, solve for x, and then we get the point -5/2, 0. It's a point on the x-axis, and that's the x-intercept. So now we have 2 points, we connect them, and then that's the graph we are looking for. So now we have the graphs of both linear equations, and we can see the intersection. And that is the solution of the system. Okay, and actually we can read the coordinates. That's -1, -3. The point of intersection of the graph is an ordered pair A, B, which represent the solution of a linear system in 2 variables. Algebraically, x equals A and y equals B make each equation true. Okay, so now let's look at 3 different scenarios with different number of solutions of a linear system. Okay, the first one, like the example we just saw, 2 lines, different slopes, and there is exactly 1 solution. Okay, so if 2 lines, they have different slopes, 1 solution. The second scenario, if 2 lines are parallel, meaning their slopes are the same, but the y-intercepts are different, then no solution. Okay, parallel lines, no solution. The third scenario, if 2 lines, they have the same slope and the same y-intercept, and then they coincide. Pretty much they are the same line. And in this case, there are infinitely many solutions. Okay, so that's the 3 different scenarios of a linear system. Now let's look at one practice question. In the xy plane, the equation 2x plus y equals 3 and the 10x plus 5y equals c represent the same line for the constant c. Then what is the value of c? Actually, we did this question before, okay? And today we're going to do it in a different way. So first, we're going to change both linear equations, which are in standard form, into slope-intercept form. The first one, 2x plus y equals 3. We move 2x to the left side. And then the second one, 10x plus 5y equals c. We move 10x to the other side. And then we solve for y, divide 5 to each side. And we get y equals -2x plus c over 5. Now, the question tells us they represent the same line. That means they have the same slope and they have the same y-intercept. Okay, and we can see from these 2 linear equations in slope-intercept form, the slopes are the same. They are both -2. Then the y-intercept must be the same as well. So equate 3 and the c over 5, and then we solve for c. c equals 15. That's exactly the same answer we did in previous videos. Okay, Okay, so now let's look at one more practice question. So we have a system, and it is known that there is no solution for the system of equations above. Find the ratio of A, B, if A and B are both constants. Okay, so now we're going to change the two linear equations into slope-intercept form again. Why is that? Because the slope-intercept form is the best form that we can see the slope and the y-intercept right away. Okay, we can compare the slopes and the y-intercept from there. Okay, the first one, we're going to solve for y, meaning move the term with x to the right side, and then we times the reciprocal of the coefficient of y. Okay, so y is by itself now, and then we solve it. So y equals negative 8/9 x plus 32 over 3. Okay, so that's the first equation. The second one, same thing. Okay, we're going to move the term with x to the right side, and then we solve for y. Okay, simplify, we get y equals a over bx minus 12 over b. Okay, so now remember, no solution for the system. Okay, no solution for the system. That's the scenario where the slopes are the same, but the y-intercept are different. Okay, so the slope are the same. So that means a over b equals negative a over 9. So the ratio of a and b is negative 8 to 9, or 8 to negative 9, okay, if you put it that way. And also remember, if there's no solution for the system, that means the y-intercept cannot be the same. Okay, so let's do one step further. Okay, so 32 over 3 cannot be equal to negative 25 over b, and we solve for b, so b cannot be negative 75 over 32. Okay, so this is not asked from the question, but that's one step further here. That's all for this lesson. Thank you for watching. Goodbye.